Hey everybody, welcome to Mammoth Interactive's YouTube channel. First of all, I want to thank you for watching this video. And remember that this channel doesn't do Patreon. Instead, we sell our digital courses down below. And every single dollar that we get from the products you buy below goes into making more content. The best way to help out this channel and Mammoth Interactive is to subscribe to Mammoth Interactive's huge library of content. Get thousands of hours and hundreds of courses for a low price down below. We have a monthly option and a yearly option. Thanks for listening, and I'll see you in the video.
Hello everyone, and welcome back to our course. In this lecture, we are going to set up our Babylon game project. Now, you can create your folders and files manually just via your File Explorer, or you can create files and folders via the terminal or command prompt application, which is what I'll be showing you here. The terminal or command prompt is a default application on your computer. It's called the terminal on Mac and the command prompt on Windows. So join me in that application and we're going to get started creating our project folder. I'm going to CD into a folder where I want to create my project. CD means I'm entering that folder, and I can check where I am with the command pwd and hitting enter, and I can see the path to where I currently am. Then I can create a new folder with the command mkdir, make directory, and I'm going to call this folder, let me zoom back in here, and I will call this folder Babylon game and hit enter. Then I have to CD into Babylon game. All right, so that is where I am. Currently, if you use ls on Mac or if you use dir on Windows, you can see the contents of your folder, and we have no contents yet. Let's create our first content, and that will be to create our index.html file to store our website. You can create a new file on Windows with the command Notepad and on Mac with the command Touch. Let's create index.html and hit enter. Now, if we list out our contents, we can see that we have index.html. Let's open up index.html with a code editor or with a text editor. Here I am inside of my code editor, Visual Studio, and I have opened up index.html. By default, it is blank, but let's start by putting in the HTML structure of our web page. We're first going to specify the document type HTML, then we'll open up the HTML tags to store all of our HTML. HTML is a markup language that stores the elements of your website. We are going to have a head tag where we can put in styles and metadata about the site. We can also add links to any content or tools that we want to load before the body of the website is shown. So we can have a body tag. Inside of the body tag is where you put in all of your elements, such as, for example, a heading 1. And you can put in this heading 1, Babylon game. If you save this file, you can already preview its contents by just opening it up with any web browser. For example, here I've opened up the file with my Firefox browser. Just by double-clicking on the file, it will open up in your default web browser. You can also choose to open it with a web browser, or you can just paste in the path to the file. And we can see our heading 1, Babylon game. So this tells me that I've been able to create the HTML file. Now let's go back into the file and let's put in here some more content. Inside of my head, I want to load in Babylon. So I'm going to specify a script. A script allows you to load in some tool like Babylon. I'm going to load it in the head so that way Babylon is loaded before we start rendering the body of our website. To load in Babylon, we can use a source for the script and we can pass in a CDN, which means we can load Babylon via the internet. I'm going to use HTTPS and then use a CDN to babylonjs.com/babylon.js. This is one way of loading in Babylon. You could also use npm and node to load in Babylon as another option. All right, so there we have Babylon loaded. If you go into your browser, refresh, you'll still have everything appear as usual because in the head, we just put in scripts, styles, and metadata. Next, inside of the body, let's put in a canvas where we will actually display our Babylon contents. So I have my heading 1, which I'll remove later, but we can keep it for now. And I'm also going to put in a canvas here. All right, so there I have my canvas HTML object. If you go into your browser and refresh, you won't see the canvas because we have to actually specify with Babylon what kind of content we want to put into the canvas. All right, now that we have our HTML file, let's create our first JavaScript file where we're going to set up the JavaScript. We'll be able to generate a Babylon engine. So join me in our next lecture where we will build our index.js file. Hello everyone and welcome back to our course. In our previous lecture, we learned how to set up our Babylon game project. Now in this lecture, we are going to create our Babylon engine inside of an index.js file. So join me inside of your project folder and in your terminal or command prompt application. Here we can see we have index.html, and I'm going to create a new file to store our Babylon engine. If you are on Windows, you can use Notepad to create a new file. If you're on Mac, you can use Touch to create a new file, or you can also just create the file manually via a code editor, or just with your File Explorer. I will create the file called index.js. This will be the entry point to the Babylon engine and the Babylon scene. So we've created the file. We can list out our contents with ls or dir. And now let's open up index.js with a code editor. Here I've opened up index.js with Visual Studio, and by default, it's just this empty file. Let's get started writing some JavaScript code in here. The first thing we have to do is create our engine. So we can use new babylon.engine, and I can use the Babylon object because I imported Babylon via a CDN inside of my index.html. This means that inside of my body, I can use Babylon. All right, so that's how I can use new babylon.engine. Now for an engine, we need to pass in several arguments, starting with a canvas. And our canvas is going to be the HTML canvas that we created earlier. Right here below our heading 1, we have this canvas object. So that is what we're going to use to render our Babylon 3D scene. Now, in order to grab the canvas, let's go into our index.js file. And here, we're going to make a variable canvas, and we can get an object by using document.getElementById. This is a function from the document, our HTML document, that allows us to find an element by its ID. Now, currently, our canvas object does not have an ID, but we can assign it an ID, such as our render canvas. All right, so that means that this is a unique identifier that can only be used one time per the HTML website. Only one element can have this ID. IDs are not reusable. If I wanted to give this heading 1 a unique identifier, I would have to use something else like heading 1. If you wanted to have a reusable property, you could have a class where you can have multiple classes that are the same name on multiple objects, but IDs, you can only have one ID per object. All right, so here we have render canvas. So that means we can use that ID in quotation marks, render canvas. It's called render canvas because that is the canvas used to render the 3D scene. All right, next up, for creating our engine, we need to pass in more arguments. Our next argument is whether we want anti-aliasing to be true. So let's create a constant anti-alias and set this to true. Anti-aliasing allows you to have a sharper image, so all of your elements will be a little bit crisper thanks to anti-aliasing. As well, we can pass in some options inside of an object, and that allows us to pass in many more engine properties, such as whether we want to preserve the drawing buffer. We'll set that to true for better performance, and whether we want to use stencils, we'll set that to true as well. All right, so then we can store this engine in a variable called engine, and that will create our engine. And then we also need to create a scene for the engine to actually render, because currently if you save everything and you go back to your index.html file in the browser, you won't actually see any changes in the browser. Because if you want to actually see 3D elements, you have to render a scene, and we'll do that shortly. One more thing we should add is an event listener for when our window resizes. So that we can add that later once we have a scene that we show. This is all we need to set up the engine. So our next step is going to be to build out a scene. So join me in our next lecture. We will build out scene.js with a new Babylon scene. Hello everyone, and welcome back to our course. In our previous lecture, we created our Babylon engine. In this lecture, we are going to create our Babylon scene and also connect the engine and the scene to our HTML file. So in your terminal or command prompt or manually, we're going to create a new file. So make sure you're inside of your project folder and then use Notepad on Windows or Touch on Mac to create scene.js. Now, it may be tempting for you to just throw everything into one file, but games can quickly get out of hand. That's why we're going to create multiple JavaScript files to represent different pieces of our site. That way, if we have to change something, we can just quickly go to the file instead of having to search through one enormous file. Now, let's open up scene.js with a code editor. Here I've opened up scene.js with my code editor. Now, before we start writing code in that, let's go into index.html, because here we have to reference every single JavaScript file that we want the website to use. Just because the file is in our project folder doesn't mean that the website will use that file. The website will only use the file if you reference that file inside of index.html or in another JavaScript file. You have to reference it somewhere. Just by existing, a file will not be automatically included in your website. So here, just before my body ends is where you typically put your JavaScript references to JavaScript files that you wrote yourself, because you want all of your elements to be loaded so that way the JavaScript files can use them. Here we're going to use a script tag, and it's going to be similar to how we referenced Babylon via a CDN. But we're going to reference our own custom script that we wrote instead of the script that creates Babylon. We specify the script source, and here we have to pass in the relative path to the folder. You could also pass in an absolute path, but the relative path is recommended because files can get moved around. So let's reference our index.js file. Now, because it's inside of the same folder as index.html, we can just specify that we want to go into the parent of this current file and go into index.js. The parent of the current file is just the project folder because we put index.html directly into our project folder. Then index.js is inside of that parent. All right, so that is how you can reference your index.js file. And by referencing it now, the code inside of index.js will get loaded inside of your website. You can go into your browser and let's see. And you can refresh. Nothing will look different, but now our engine is actually being loaded into the website. Whereas before, yes, we did create the engine, but we never actually loaded it in. Now we have to do the same thing for every single file that we want to be included, such as scene.js. So whenever you create a file, make sure you include a reference to it inside of your HTML. Otherwise, the content and code inside of the file will not be loaded into the website. Great, now we can actually build our scene inside of scene.js. Here I'm going to create a variable called build scene, and it will store a function. In here I'm going to create a new scene. So I will create a variable scene, and I will use new babylon.scene. Now for this I have to pass in an engine, because in order to be able to build a scene with babylon.scene, we have to pass in the argument containing the actual engine. So that's why I'm passing in new babylon.scene, and then the engine. All right, now where am I going to call build scene? I'm going to call it inside of index.js. So here inside of index.js, after I've built out the engine, I am going to create a variable scene, and I'm going to use the function build scene. So yes, I can use variables and functions from different files as long as it has been loaded in, which we did via our HTML file. All right, so that is how we can call this function to build the scene. All right, now what about the engine? Where is the engine coming from? That is going to come from index.js. So these two files are working together. All right, next, how do we actually put in a scene? Let's put in some simple Babylon elements into our scene, such as we could put in a camera and a light. We will add all of those in later. For now, let's make a build scene here, and this function has to return the scene, because if you want a variable to store a function like build scene here, then we have to have that function return something. Then inside of scene.js is where we'll put all of our elements later. Okay, so we've called build scene. Next, we need to call engine.runRenderLoop, and this will here be a function. Just make sure you spell engine correctly. Okay, here we are going to perform a check. If scene is not null, so if scene, then we'll call scene.render to build out the scene. If you go into your browser currently, you can refresh, and currently we won't see any new content added because we don't actually have anything inside of our scene. But if we put something in here, like a camera or a light or players, then we would be able to see that content, because now we've combined the scene with our index, right? And if at any point you don't see what I'm seeing, you can view your developer tools by going into your browser and selecting more tools and then opening web developer tools. It's kind of different on each browser, but it's around in the same location. Okay, you can also right click and select inspect. That is another quick way to access the web developer tools. The web developer console will be your best friend because it will tell you any errors and where they're located. So for example, here we have this message, build scene is not defined. Okay, so we have to make sure that build scene is defined in index.js at line 12. So let's go into our line 12. Okay, so the reason that we're getting the message that build scene is not defined is because we have to actually call scene before we call index. So this index file is using build scene, which is inside of scene.js, which means we have to make sure that scene.js is loaded before index.js. So that way, all of the functions and variables inside of scene.js will get loaded, and then index.js can use them. All right, so now we can save our changes and refresh our page, and now let's see what we get inside of our console. This time the message that we get is no camera defined. So we were able to successfully load in our scene into index.js. Now we just need a camera. Okay, so our Babylon scene is asking us for a camera, which we will create coming up next. The camera will actually allow us to display something in the scene. Otherwise, we do have a Babylon scene right now, but it doesn't actually have any content or any way to render the content. So join me in our next lecture. We are going to define a camera. Hello everyone, and welcome back to our course. In our previous lecture, we built out our scene for our game. And currently we don't have any content in the scene. So the first thing we need is a camera. So we are going to create a new file to store our camera, because if we look at our files currently, we don't actually have a camera created. So join me in your terminal or command prompt, or just manually create your file. We'll create the file with Notepad on Windows or Touch on Mac. The file will be called camera.js. All right, now let's open up camera.js with a code editor, and we will build out our camera. Here I have created camera.js. Now inside of our scene.js is where we're going to reference the camera. So before we return the scene, we'll call build camera. This function will be inside of camera.js. So let's create a function build camera, and in here we will put in the Babylon camera. So I'll make a variable camera, and I'm going to instantiate a new Babylon.follow camera. We're using a follow camera, which is popular for third-person games because this camera can actually follow around an object like the player. Here we'll pass in the name for this object. We'll call it the camera. We can also set here a position for it. So I'm going to set that to a new Babylon.vector3. A vector 3 is a point in space on 3 dimensions, x, y, and z. So I'll put it at 0, 1, 1. Now, one more argument we need is the scene itself. This refers to the scene where the camera will be used. So we are using our scene. Okay, and here we are now building out our camera. Now let's reference camera.js. And because it's being called inside of scene.js, that means we have to reference camera.js before scene.js. So let's make a reference to the file. Now, if you go into your browser and you refresh the page here, now we have our camera that's been created. All right, and you can also see now on your page, you have this navy or dark blue purple rectangle. This is actually our scene. So we now can see something because our camera is working. All right, so we are able to see that camera that we created. The camera is put to work, showing us a scene. The current scene shows us absolutely nothing except this background. All right, let's go into our index.html. I'm just going to remove the heading 1. Okay, here I'm going to refresh my page, okay, because I don't want the heading. I want my camera to take up the full screen. I want it to take up all of my view because currently if I go to 100% zoom, this is actually what my camera looks like. It's quite small, the scene body. So I can actually increase the size of my canvas. For that, I'm going to go into my index.html. So we have our camera built out, and you can set a lot of different properties of the camera to fine-tune it. But let's first begin by changing our render canvas. So inside of a style file, we want to be able to here put some kind of style on the render canvas so that it actually is able to take up the full screen. So here inside of my head, I've loaded in Babylon.js. That's great. I'm going to here load in another script, and that will be for my style.css, which will style different elements of the page. So here I'll make a tag link, then I'll have the relation, which will be style sheet, and I'll have the hyperlink reference to be in my parent folder, and then style.css. So here I've used a link tag, and the relation is a style sheet. This is the convention for loading in a style sheet. The hyperlink reference or location of the style sheet is style.css in my parent folder. So I do have to create that file. Inside of our terminal, let's use Notepad or Touch to create style.css. Then let's open up style.css with a code editor. Here I've opened up style.css, and we are going to grab our canvas element and we are going to style it. I want its width to be 100% and its height to be 100%. So here we've taken our canvas element and we've used curly brackets, the convention for CSS, and we've set two properties, width and height, to be 100%. This means that the height and width of the canvas will be 100% of its immediate parent. If you refresh your page, you'll see that your canvas will be a lot bigger. Now, as well, you want to put width and height on your HTML and your body. So let's go into our style.css, and at the top, typically the first thing you want to style is your HTML tag and your body tag, because those contain all of your contents, and we're going to set their width and height to 100% as well. Refresh the page and your canvas will be just a little bit bigger. I'm also going to set margin and padding to 0, so that way there's no little bit of padding or margin on the edge of the canvas. So I'm going to add another property, margin 0, that is the space around the canvas or the HTML or the body. In this case, just the HTML and body. And padding I'll set to 0, that is the space inside of an element around the element. So we can go into our browser and refresh, and now look at that, we don't have any more white space around the canvas. So this creates a more immersive experience. Now you may also want to get rid of this pesky scroll bar that can appear, and to do that we can set another CSS property, just one more, that will be the overflow. We'll set overflow to hidden, which means that any content that's overflowing, like a scroll, will just be hidden. So if I refresh, my scroll bar will be gone. Amazing. So I have been able to render my scene with my camera, and of course currently is just the default Babylon background color. All right, coming up next, now that we have our camera built out, there are many more properties that we can set on the camera, like its radius and its speed, collisions, and more. But first, let's put in a player and a light and a ground so we can actually see some content with our camera, because currently it's like we're looking into the void. So join me. Coming up in our next lecture, we will add a player. Hello everyone, and welcome back to our course. In our previous lecture, we created our scene with a camera so we could actually see the background of our Babylon scene. In this lecture, we are going to create our player so we can actually see something in the scene. Then we can adjust more settings and add more objects. So join me inside of your project folder. Here we are going to create a new file with Notepad on Windows or with Touch on Mac. It will be called player.js. Then let's open up player.js with a code editor, and here we'll build our player. Here I've opened up player.js with Visual Studio, and I'm going to, before I start referencing player, let's go ahead and go into our scene, because here we built a camera and our next step will be to build a player. So we're calling the function build player. We'll therefore have to build that function inside of player.js. Now, because the scene is using the player, we have to make sure we load the player before we load the scene. So here I'm going to have a script source to my player.js. All right. Then inside of my player.js, let's create a new Babylon player. So I'll make a variable player mesh, and I'm going to use babylon.mesh.createBox. So I'll just have a box representing my player. Later on, after you've built out the core functionality of the game, you can add in models. The best way to develop is to develop the game first and do the art later. So I'm going to just use simple primitives for beginning the prototype of the game. We are going to call the box the player mesh. Then we can set here our box size to 1.0, and the scene is where the box will be created. So here I've specified some arguments for my box. I'm just going to change here the 1 into a constant called player size, because typically you don't want to leave numbers around without having a definition for what those numbers represent. All right, so we've created a player mesh. We've given it a name, it's just a box, and we've given it a size and specified into which scene do we want to put this object. So just by declaring the box, we have already added it to the scene because we specified the scene where we want to put the player. If you test out your project, you still will not see any player. even though we won't have any issues in the console except about the character encoding of our HTML document, which we can easily fix with HTML. So how do we get the player to appear? Well, we have to add another line into our file here to be able to actually show the player in our specific type of camera. We need to take our camera and we need to set the locked target property to the player mesh, because currently, yes, we have a camera, but we don't have any locked property set. So this is the property that sets what the player is going to follow, because we do have a follow camera. So the locked target means that the camera will be locked on the player. Now, if we test this out currently, refresh, we can see our player appear. Okay, so there is the player appearing in our camera's view. Now, for this to work, you have to make sure that your camera variable is accessible to the player. So the player has to be able to see this camera. Now, before we had this as a var camera, so you have to be a bit careful here, because we have our index, which is calling build scene. Then build scene is building the camera and then building the player. If we here declare this as a var camera and then we refresh the page, we'll actually get an error message. And that error message is going to say that camera is not defined. So we have to actually make this a global variable by deleting that var here, which means that all of our files can now access the camera. So if I refresh the page, I can see the player. You could also make a constants or a globals file. The globals file can keep all of your global variables like the camera. All right, so that way you can make sure all files can reference the camera. If you still want to use var camera, you would have to just declare the camera in a separate file, or you can just remove the var, and that way the variable is automatically made global so that multiple files can access it. Okay, so we have here our camera and we are showing our player. There we go. We can see that is the player currently. Let me refresh. All right, so that is the player. It is a box of size 1 by 1 by 1. Currently, we can't move around or anything. We are going to add that functionality later, how to move. There's a lot more properties we can set on the camera as well. Like you can set the camera to be farther away and to process collisions and apply gravity. So we'll work on that later on. But for now, we have our player added. Our next step that we are going to add in is going to be player ground. So we'll have a ground, so that way we can move the player later and we'll be able to see the players actually moving. So join me in our next lecture. We will add the ground for the player to walk on. Hello everyone and welcome back to our course. In our previous section we created a player and learned how we can make that player appear. Now there's a lot more fine-tuning we can do of the camera and more on the scene, and we'll add that in later. For now, let's build out the ground for the player to walk on, and then later on the controls and movement of the player. So open up your code editor and join me inside of your file scene.js. Here we have called build camera and build player. Now let's add in a ground. So for that, I'm going to call a function called build ground, and I can build this function right here inside of my scene.js because it is part of the scene, the ground. It doesn't have to be its own file, at least not for now. So let's build out a function build ground. Make sure you use the function keyword. Here we are going to make a variable ground and use babylon.mesh builder, and we'll use the function create ground. We'll put a name for the ground to be ground, and then we'll put in some options here. Then we'll end the line with a semicolon. Our options for the ground are going to be our width, and we'll create a constant called size of ground. So here let's create a constant size underscore of underscore ground. You could also put all of your constants into one file if you want easy checking of all of the constants. That can be useful. So let's define a size. Let's do 30. Okay, so we have our width, size of ground. Let's set the height of the plane to be the same size of ground, and our subdivisions will be 1. All right, after the options, we'll pass in what is the scene into which we want to put the ground, and that will just be our scene variable. All right, so that is going to add a ground into our game. We can preview by refreshing. Okay, now you can see we have this long plane that's appeared. Every time I refresh, I see that long plane. Okay, and also my cube has disappeared. It looks like it is just inside of the plane, but you just can't see it because it's the same color. So we can add a light to be able to see our cube. For that, we're going to go into our scene.js and let's build out another function to build a light. So I'll call this build light, and I'll just create it around the same area as building the ground. It's a function called build light. And I'm going to use a Babylon light object. So I'll make a variable called light, and I'll instantiate a new Babylon.pointLight called light. Then I'm going to set the light positions. Let's create here light position. This will be a constant. I'll define a const light position to be a new Babylon dot vector 3 at position 0, 5, 0 to start. And finally, we need the actual scene where we're adding the light, which is our scene variable. That is going to give some light to the scene, so I will refresh. And look at this, now we can see our plane and also our player. Okay, and we can see the light, which is the point light shining down. So this white spot is actually the light. We can change the light's intensity and range. So all you have to do is go into the light. For example, I can set light.range to equal 20. If I go back to my browser and refresh, look at this. Now the range of the light has changed. Right? And I can change this to 100. I can go into my browser, refresh, and again, the range has changed. One thing else is the light's intensity. So I'll set light.intensity. And there are many other properties of the light, so you can fine tune how you want your light to look. You could even change the light color. So here I've changed the intensity to 2, and that's a lot brighter. I could change it to 1.5 and go back and refresh. It's not as bright anymore. So you see, you can change up different properties of your light to however you see fit. All right, so there we have our player and our ground. Now our player is kind of sunken into the ground, but we can move it later. If you want it to move up, you have to change its position on the y-axis. So for that, we can go into our code editor and go into player.js, and we can take the player mesh, and set its position.y, which means the position on the y-axis, and we can change that to 1. Then I can go into my browser and refresh, and look at that. Now the player is on top of the plane. It's not sinking down. And we'll adjust colors later on. Okay, so we have put in a ground. We could change the color of the ground as well. We'll take a look at colors later on. Great, now that we have built a ground, we can implement player movement. So join me in our next lecture. We are going to learn how to add in controls so that our user can use the keyboard or the mouse or whatever kind of controller you want to enable in order to move their player. Hello everyone, and welcome back to our course. Previously, we learned how to add in a ground and a light to our scene. In this lecture, we're setting up controls so that we can take user input to move the player around. We're going to be using WASD controls, which are controls that players are familiar with, using the W key on the keyboard to move forward, using S to move backward, using A to move left, using D to move right. You could also do W to move forward, S to move backward, A and D for rotation. We can take a look at different ways to move our player. You can manipulate different movements of the player to get a different effect. You can get the effect of a car rolling around a street, or a sphere rolling down a hill, or a player walking. Whatever kind of game you want to create, movement can really change a game. It can make your game better or worse, or it can make your game just different depending on what kind of experience you're trying to give or what kind of player you have or how complex your game is to create or to play. So movement is a big thing. We're going to be using WASD. You want to use keys or controls that your users are familiar with. You don't want to invent your own system of controls like T for jumping, G for moving forward, P for moving right. You want to keep a control system that users are familiar with, and WASD has been around for a long time. So in this lecture, we're setting up the controls. So join me in your terminal. Here inside of our project folder, we are going to create a new file with Notepad on Windows or Touch on Mac that will be called controls.js. This file is going to store all of our controls. So let's open up controls.js with a code editor. Here I've opened up controls.js with my code editor. Before we add code to it, let's reference controls.js. Now you may be wondering, where do we put it on the list? Well, we're going to call controls inside of scene. So here we have building our player, building our light, building our ground, and then let's call build controls. So because we're using this in the scene, we want to make sure we load in the file before the scene. So just make sure you put it before the scene as a script source. It will be in the parent folder /controls.js. Make sure you spell it right. All right, and then we can go into controls.js and we can build out that function, build controls, which we already referenced in our scene. Okay, so let's get started here. Here we're going to add a document.addEventListener function. What this does is it allows us to listen for some kind of event that's happened in the document or the website. The document refers to the HTML document. An event can be like a refresh of the page. It can be a click on the page. It can be a key down on the page when someone presses a key or releases a key. There are many events that happen. It's basically anything that a user does when they go to their site. You can listen for anything that they do. And we are going to listen for when they press down on a key. So for that, we add an event listener and we're listening for the type that is key down. This is a specific event listener type that comes from document.addEventListener. There are many other event types as well, like mouse down, mouse up, and key up. So here we're taking in key down, and we're going to as well take in some event. This is the event that happened. This refers to that key down event. Now make sure you close up the key down function. Okay, you want to close it outside of these curly brackets. So you have the curly bracket, then you have the parentheses. Okay, so we have this event. Then we need our arrow syntax from ES6. This allows us to have a callback function. So what we're writing here is we're listening for this event, and whenever that event is fired or triggered, run some code in this callback function. So these curly brackets, they open up the callback function thanks to the arrow syntax. All right, so here we can put in what we want to do when we get a key down event. The key down event will be triggered when any key is pressed or held on the keyboard by your client, your website user. So what we want to do is perform a check. We'll check what key code was actually pressed. What key was pressed? Did they press W? Did they press A? Did they press S? Did they press D? Did they press 9? So to check what was pressed, we can use an if statement, and here we'll check if event.keycode is equal to a certain value. All right, then we can use curly brackets to specify what we want to happen if the if statement is true. So here, we're going to listen for a key code for the W key. So let's create a constant called the W key. This has the key code 87. So every key on your keyboard has a key code, which you can search up on the web for a key code for the key W, or you can go to keycode.info, the website. The key code for W is 87. So that is why we are referencing event.keycode, checking if it's equal to W_key. All right, if the event.keycode is equal to W key, we can do something, such as call console.log that W was pressed. It's good to use logs to test out your code. So let's test out, is this code working? Because right now, if I press the W key, I should see logged out, W was pressed. So I'm going to go into my browser, refresh my page. I'm going to open up my developer console with the Command-Alt-I shortcut, or just right-click and then inspect. Okay, here I can see what's inside of my developer console. I can zoom in a little bit on the text as well. And here, if I press the W key, now right now I'm in the console, so I have to make sure I click out of the console and that I'm not typing anything into the developer console. So I'm going to click on my Babylon game, and if I press W, look at that, I get the message W was pressed. And if I hold it, I can actually see that number will go up. Okay, so as I hold it, the W key is pressed, and every time I press it once, it will go up. If I stop pressing or holding, the number will stop going up. So that tells me that I'm logging out, W was pressed. This number tells me how many times W was pressed is logged out. In this case, it's been logged out 87 times. If I press W again, that number will change to 88 because W was pressed was logged out 88 times because I pressed W or I held W for a certain length of time. So even as you hold the key, the number will still go up because the key is being pressed. All right, so this tells me we were able to listen for a key like W on my keyboard. I can go back into my code editor and console.log W was pressed. This line is working, which tells me that my event listener is working. Now, I don't actually want to log this out. What I want to do is set a variable, is W pressed, or just W pressed. And this is going to be either true or false if the W key is currently pressed or not. Then I'm going to use this variable later in a different file when I want to move the player. And I will move the player forward if W is pressed. I will not move them forward if W is not pressed at any moment in time. Okay, we can still keep these logs just for testing purposes, but you want to remove them if you're going into production because the logs can actually slow down your website. Okay, so we've checked for the W key. Let's check for a whole bunch of other keys as well. I'm going to check if event.keycode is equal to my next key, which will be the A key. So I'm going to make a constant at the top of the file for the A key. And the key code for A is 65. So I have to make sure I reference that because the key code doesn't go by just the letter A. If that event is true, I can call console.log and I can log out A was pressed. And I can also set A pressed to equal true. Note that I'm not declaring these as a variable, which means they'll be global. If I had var here, they would be local. That's because I want to use these in another file. Okay, I'm going to refresh my browser, and this time I can press W or I can press A, and I can see those items will be logged out. Awesome, let's go back into our code editor and let's do two more keys. We need S and D because W is moving forward, A is moving left, S is moving backward, and D is moving right. Another option is to have W moving forward, S moving backward, and then A and D for rotation. And we'll take a look at the different options. Okay, so here I'm going to add another if statement for event.keycode, checking if we have pressed the S key. All right, and here I'm going to define a constant for the S key. The key code for the S key is 83. All right, then I'm going to scroll down, and if S key is pressed, I'll call console.log S was pressed. Then I will set S pressed to equal true. I can save this and test it out by refreshing my browser. I can hit W, A, and S, and look at that. Now I can see W, A, and S are being registered. Then let's go back into our code editor and let's just put in one more. We need to check if the event.keycode is equal to the last key, the D key. We won't check anymore, although you could if you wanted to implement stuff like jumping with a space bar. You just have to do another if statement for a different key. Let's create the D key constant. So the key code for the D key is 68. Let's go ahead and inside of the if statement here, I'm going to call console.log and I am going to log out that D was pressed. I will also set D pressed to equal true. I'll save all that. Then I'm going to go into my browser, refresh the page. Now I can enter W, A, S, D, and I can see both of those new ones are being registered. Awesome. Now, we also need to check for if a key is released, because otherwise D is pressed will always be true even if I only pressed D one time. But I want to make sure I set these to false when my key is not being held. So for that, we'll do a very similar process. I'm going to copy all of this code for my event listener. Just copy it all up and then paste it right after, because we're just going to change a few things. Key down, we're going to change to key up. All right, because now we're listening for when a key is released. We want to listen for all 4 keys, but this time we're going to log out that the keys were released instead of pressed. So let's change that to released, released, released. And also we want to set the Boolean variables pressed for each key to be false, because now the key is no longer pressed, it is released. So this means I can move my player when its key for a direction is true, and I can stop the movement immediately as soon as the key is released. Let's save this file and then go into our browser and refresh. This time I can press W, and if I press it once, I get W was pressed and W was released. If I press and hold, then I get W was pressed, then I release and I get W was released. And we can do this for each of our other keys. Okay, I've pressed all those, and then if I held one, I see D was pressed and I can release. Okay, great. So this tells me we've built out our controls. Now, how do we actually get these controls to move the player? Because currently the player is a sitting duck just sitting there. So join me in our next lecture. We're going to actually implement movement using our controls. So we'll use those variables that we created, the W pressed, A pressed, S pressed, and D pressed. We'll use those to actually move the player. So join me in the next lecture. Hello everyone, and welcome back to our course. In our previous lecture, we built out our player controls, and in this lecture, we're going to use those controls to move the player. So I want to create a new file in my project with Notepad on Windows or Touch on Mac. That file will be called movement.js, and let's hit enter, and there we go. Now let's open up the file with a code editor. Great, here I've opened up movement.js. Now inside of this scene is where we're going to build movement. So after we've built out controls, we're going to build player movement. And we'll build out that function inside of movement.js. We'll have a function called build player movement. Now because we're using movement inside of scene, we want to make sure we reference movement before scene. We have to load it. So here I'm going to go into my index.html file and I'm going to load in movement.js. All right, now let's get started implementing the player movement itself. Here we're going to call scene.register before render. So we're putting to use our scene variable and we'll have a function. So scene.register before render comes from Babylon.js, and what this function is going to do is it's going to set up something before we render the scene. So we want to register player movement before we have our scene. For that, here I'm going to perform a check. If the scene is not ready yet, then I'm going to just return out of the function. I have to make sure the scene is ready before I can implement player movement. Otherwise, if I try to implement player movement before the scene is ready, it will never get implemented properly and the game will just break for whoever is trying to load it at that exact time. Okay, now we are going to perform a check for one of our keys if W pressed. So this was a variable that is true if the W key is pressed at any point in time. All right, and this is actually going to be checked continuously throughout the game. We'll have if W pressed, it will be listened for because we have registered it. Here, if our W key is pressed, there are many ways to move a player. Here, let's start by grabbing the player mesh and using our function locally translate. This is one way of moving the player. Here I'm going to pass in a new babylon.vector3 for how much I want to move the player. So I can even make a constant here for movement amount and put the vector3 into that movement amount. Okay, you could put this just above locally translate and put this as 0, 0, and 0.1. So I'll just translate the player on the z-axis. Then here, when I call locally translate, I want to pass in the movement amount. All right, and we can already test this out. Now, for this to work, we have to make sure that we can access W pressed and scene and player mesh in a different function. So if we have our player here, we have player mesh is currently local. So we just have to make sure that it's available in movement. Now, if you test this out now, you'll get a lot of messages about the scene being undefined and similar. And you may be wondering what's going on. If you have all of your code as expected, you don't have any extraneous parentheses or curly brackets. Well, the reason is that we have to make sure that our variables are global if we want to use them across different files. Because currently you can see in our index.js, we defined a variable scene, which means it's only accessible in this file. We can remove the variable declaration to make it global or put it into a constants file or a globals file where we define all of the global variables there and then we load that as the first file. So we have to make sure we do that anywhere we declare the scene. Okay, it can be useful to change it to make it global. We have to do that also for any other variables that we use, like W pressed. Okay, inside of our controls, W pressed, yes, it actually is currently global, but the thing is, it's only going to be created here when W has been triggered, but we actually need access to the pressed variables before they may be created. So for that, let's go ahead and define the pressed variables. I'm going to define W pressed to be false, S pressed to be false, then A pressed to be false, and D pressed to be false. So these will be global. I'm just defining them to false so that I can use them even before they have been created. So that way they're actually created, because otherwise they wouldn't be created until this event listener was triggered. Now, one more thing we also have is the player mesh. We also have to make that global. So inside of our player, we have to make sure we remove that var to make this global. Now we can go into our browser and we can refresh. And now we can go ahead and press some of our buttons, okay, some of our keys, and look at that. Now if I press W, my player will actually move. So let me refresh again. Press W. It gets stretched sometimes if you change your windows and you didn't set up to prevent stretching. All right, so here I'm pressing W and I'm moving in one direction. Awesome. Okay, so that tells me I've been able to implement movement in one key. Now, of course, we want to add in other keys for the movement. We want to add in the D key, the A key, and the S key. Next, let's implement the S key to move our player backward. So for that, I'm going to add an if statement and check if S pressed is true. I am going to define a const movement amount again, and I'm going to here use new Babylon dot vector 3. I'm going to choose 0 and 0 for the X and Y, and then negative 0.1 for the Z. So this is going to move backwards the player. Then we can call player mesh.locally translate, and we can pass in here backwards. Now let's save this file and go into the browser and we'll refresh. Now we can see if we hit W and if we hit S, we'll move forward and backward. Okay, now these two look like they are a little bit flipped. So right now if I'm moving backward, it's with the W key. If I'm moving forward, it's with the S key. So we want to rotate the camera around the local origin of our target. So we want to rotate the camera around, because currently if I try to use 0.1, it's actually moving me backward. So let's go into our code editor, and here I am going to open up my camera and I'm going to rotate it. So I'll use camera.rotation offset and I'm going to use 180 degrees. This will be the goal rotation of the camera around the local origin or the center in the XY plane. So 180 will be a const that is the amount of rotation. All right, and we have 180 because we want to rotate it half a circle. So now I'm going to refresh my page. If I press W, okay, great. Now W moves me forward and S moves me backward. Okay, awesome. And we can check inside of our console and all of our controls are working as expected. Okay, now let's implement moving left and right with A and D. So I'm going to go into movement.js. And here I'm going to add another if statement. I will check if A pressed is true. Then we can define a constant to move left with a new Babylon.vector3. Now we want to move left on the x-axis, so I'm going to use here negative 0.1 on the x-axis and 0 and 0 for the y and z. Then I'm going to call my player mesh and call locally translate to the left. Now I'm going to save this and go into my browser and refresh. And look at this, now I can move to the left. And I can also move on a diagonal. All I have to do is press multiple keys at once. Okay, then I can move diagonally. All right, now let's implement one more key, moving to the right. So I'm going to go into my code editor, and here I'm going to check if the D key is pressed. Then I'll make a const to move to the right. The direction will be Babylon.vector3. And we're going to move 0.1 because to the right is a positive value. Now that we have flipped our camera to be facing the proper way. And we have 0 for Y and 0 for Z. Then I'm going to grab the player mesh and locally translate to the right. And now we're going to refresh our browser and look at that. Now we can move to the right. And if you press left and right at the same time, you stop. Same with W and S. All right, so that is how you can implement some basic movement. Now coming up next, we're going to add rotation to the movement because currently our player is kind of stuck looking in one direction. And that's fine for a lot of games. For example, if you had a game where you're a runner on a racetrack or you're a car going down a track, it's okay to have this kind of movement because you're just moving in one direction. But if you have more of an open world, a role-playing game, then you'll likely want your player to be able to rotate around, especially if you have a larger racetrack for a car game or something similar. So coming up next, we're going to learn how we can implement rotation into this movement. Hello everyone and welcome back to our course. In our previous lecture, we learned how to implement player movement. Now in this lecture, we're going to learn how to add rotation to the movement. So it will be a different rotation and way of movement in general in the game. So join me inside of movement.js. Here we're going to change how we move. So instead of moving with a locally translate, we're going to use a different function called move with collisions. So let's start with the W key. I'm going to call player mesh.move with collisions. And I'm going to pass in my movement direction, which will be to move forward. So let's remove this locally translate and let's define a const forward, which will be slightly different. We're going to use a new Babylon.vector3, and here we're going to pass in an X value, a Y value, and a Z value. So we will no longer be using movement amount. Now let's define X, Y, and Z, which we will reuse. So here I'm going to make a const X, and I am going to grab a player speed, which I will define as well. So let's make a const player speed to be 0.1. And I'm going to multiply that by parsing a float, so getting a float from math.sign of my player mesh.rotation.y. So we need player mesh.rotation.y, which will give us where the player is facing. Then we take the sign of that to get how much we should move on the x axis. That will be our X value. Now you may be thinking we do a similar thing for Y, but Y is actually up-down movement. So Y is going to be 0 because we don't want our player to move up and down. You could enable Y, you could enable jumping if you wanted to. We'll stick to no jumping just for simplicity. Now let's define a Z. This will be player speed times parse float of math.cosine on the player mesh.rotation.y. So again, we're getting where the player is facing and we're getting the cosine of that, which will give us how much we should move on the Z axis. Okay, now we can save this. All right, and let's go ahead and pop open the browser and refresh. Okay, now here if I press W, I can actually still move. Now that I'm pressing S, this I'm pressing A. With W, I'm still moving forward. So how do we actually allow rotation? For that, we have to add rotation to the player if the A or D key is pressed. So currently, when we press A or D, we just move left with locally translating the player, just moving them over. But instead of that, I'm going to add rotation to the player. So I'm going to call player mesh.addRotation. Then here we're going to pass in how much we want to rotate. We don't want to rotate on the X or Z axes, we just want to rotate on the Y axis. Because if you rotate on the Y axis, it's like you're looking around. Whereas if you rotate on the X or Z axis, it's like you're doing a somersault or you're spinning instead of looking around. So here, let's pass in some rotation amount. And I'm going to, for that, create a const rotation amount, and let's just set this to a value like 0.05. Then I'll pass in that rotation amount for Y, and I'm going to remove the way that I previously used the A key, which is valid. You could use the previous movement, but this is just going to be a different way of movement that's a little more fine-tuned and better for third-person and first-person games. Alright, so then I'm going to refresh my page. Okay, now you'll notice if I press my A key, I can actually spin. So I can look around by moving. And if I press the D key, it's still as before. But now I can use my A to rotate around and my W to move forward. Now I can only move to the right. I can only spin clockwise if I press the A key, because I'm adding a rotation of negative, or I'm adding a rotation of positive 0.05. Now, you actually want to put it as negative because when you hit A, you should be spinning to the left. So I'm just going to change this to negative rotation amount, and then I'm going to refresh the page, and this time I'm going to be spinning in the opposite direction. Okay, now you can see why we needed it here on this Y, because I could show you how you rotate on other axes. So I'll just comment this out temporarily, which means the code will be hidden from the compiler, and I could put the rotation amount on the X-axis instead. Then if I go into my browser and I refresh, let's say I press A, look at that, this time I'm spinning in a different way, and I'm keep zooming in as well, just probably due to some glitch. So you can see here that is if we were going to be rotating on the X axis. Now what if we were rotating on the Z axis? We can go ahead and test that out as well. I'm still pressing the same key A, but you see I'm spinning on a different axis. So that is why we needed to have our rotation amount to be on the Y axis. And then we put it as negative so that we rotate to the left, because the A key is associated with left movements, moving to the left or rotating to the left. Okay, let's do a similar thing for rotating to the right. I'm going to remove the code of how we previously used the D key, and instead I'm going to use player mesh.addRotation. Here I'm going to pass in 0 and then my positive rotation amount and then 0. So this will rotate me to the right if I press the D key. So look at this, now I can rotate left and I can rotate right. And I can still move forward and back, but I do want to change how I move back because we're still using locally translate. But if you're doing rotation, it's best to not use locally translate. And in general, it's better to use move with collisions, so that way you can actually process collisions on movements. We want to be able to process collisions so that way we can listen for when we collide with a player or something similar. Okay, so here I'm going to remove how we previously moved backwards, and I'm going to create a constant backward and use new Babylon.vector3. This time I'm going to pass in a negative x, the same y, and then a negative z. So I'm moving in the negative direction on the x and z axes. Okay, just make sure you spell backward correctly. All right, and then we can call player mesh.moveWithCollisions. And we're going to pass in backward as the direction of the movement. Then I can save the file and refresh my browser, and now I can move back, okay? And I can still rotate and move forward, and I can rotate and move back. Okay, and that is just going to be a lot better because we can handle collisions with the movement, and we now are looking more like a third person or a first person game because we can run around our tiny little world here, and we can look around it as well and go in whatever direction we like. Also, the movement is a lot smoother now. Awesome, so that is how we can build out player movement and take in user input. Join me in our next section. We're going to learn how we can add more game objects like enemies and power-ups and food to the game.
Hey everyone, thanks for watching this course. If you want to watch the rest of the course, the link is down below. Not only will you get the access to this course, but you'll get access to a lot of other courses in a huge bundle, and it's on sale today. So buy it before the sale ends. Thanks for watching, and I'll see you in another video.